Good morning, dear students. So this is video lecture number 5, and in this video we discussed about impulse of a force and Newton's third law of motion. So I think Newton's first law and Newton's second law is clear to all of you. Now it comes what is impulse of a force, rate of change of momentum is clear. Momentum is mass into velocity. Initial momentum is mass into u. Initial velocity, final momentum is mass into final velocity. Now the new terms that is impulse. So open your notebook and write impulse of a force. Impulse of a force. So it is the quantity which is used to get an idea about the change in dynamical state of a moving body. How a body change from its original position to its final position. Okay. So mathematically, impulse it is equal to product of force and small time interval. Okay. So J equal to small time interval. So it is denoted by capital J. So capital J equal to F into delta T. Force into change in time. So J equal to F into delta T. So it is also a vector quantity. So we can say that J equal to F into delta T. Here delta T is very small. F is large and delta T tending to 0. So we all know that J equal to F into delta. Delta T tending to 0 and F value is large. Okay. So if we define J, F equal to ma into delta T. And what is acceleration into time? That is change in velocity. So mv minus c. Here is the vector sign. So v vector minus u vector. So we can say j vector equal to mv vector minus mu vector. So j vector is what? P final minus P initial. So j vector equal to delta P, or we can say that impulse equal to change in momentum. Change in momentum. Okay. So this point is clear. Not impulse equal to change in momentum. So impulse is clear. So it is written that momentum of a particle is the impulse required to bring the particle from to rest present motion. Okay. Now what is the unit of impulse and what is the dimension? So right, unit, if we're talking about SI unit, so J equal to F into delta T. So force unit is Newton and delta T is second. So SI unit is Newton second. Okay. Now if we are talking about dimension, so dimension equal to F dimension is MLT minus 2 and delta T dimension is capital T. So the dimension of impulse is MLT minus 1. Okay. So dimension and unit both are clear. Now some concepts or examples that is based on the impulse. So uses or illustration examples illustration. Okay. First, first is a cricketer moves his hand. A cricketer moves his hand backward while catching a ball. While catching a ball, a cricketer moves his hand backward while catching a ball so that delta t will be large, so that force will be minimized. Now vehicles, cars, second example. That means vehicles, vehicles like cars, scooters are provided with shockers. Are provided with shockers. Okay, so that delta t will be large and force will be minimized. With this formula, J equal to F into delta T. If J is constant, then force is inversely proportional to delta T. So if delta T will be large, if delta T is large, then force will be small or minimized. Clear? Okay, so now Newton's third law of motion. Newton's third law of motion is very simple. That is, every action there is an equal and opposite reaction. This is the simple definition in class 11 physics. So write the heading Newton's third law of motion. So Newton's third law of motion, that is, to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. Okay. Suppose if a body is collide with, if a body A is in collision with B, then A and B are like this. This is body A and this is body B. Okay, so A body applying some force on B. So this is the force that is applied on A. So this is F A B, force on A due to B, and this is F B A, force on B due to A. So F A B equal to minus F B A, because both the forces are equal and the direction is opposite to each other. So what is FAB? FAB is the force on A due to B. Okay, so FAB is clear. Direction is clear to all of you. Okay, students. So Newton's third law is very simple. FAB equal to minus FBA. There is to every action there is an equal and opposite reaction. For Newton's third law, there are always two bodies. One is applying action and the other is giving reaction to the body. Examples: walking on a ground, pulling a cart by horse. So, right example. Examples: walking on ground, pulling a cart by horse. Okay, so these are the examples for Newton's third law of motion. Okay, students. Bye bye. Take care, all of you.